Hello. In this video, we want to find the intervals in which the following function is increasing or decreasing. Locate all points where the tangent line is horizontal. And then graph the function. We'll just graph it using the calculator. Now, well, it's actually graphed for us down here, but we'll come back to that. Now, f of x equals x cubed plus 3x squared minus 9x plus 4. And what we want to do in order to do this, we want to find the critical numbers. So to find the critical numbers, I'm going to abbreviate that as Cn, we need to find the first derivative. It's where the first derivative is equal to 0. So let's go ahead and take the derivative of this function, which is just a polynomial function. It's pretty easy to do. So bring the 3 down in front, making that 3x squared, and then plus bring the 2 down in front, makes that 6x, and then minus 9 at the end. And all of that's equal to 0. And to find the critical numbers here, because it's just a polynomial, we can just set everything equal to 0 and solve. Well, in this case, everything's divisible by 3, so I'm going to divide everything in here by 3, just to make everything easier. That's going to give me x squared plus 2x, my apologies, minus 3 is equal to 0. And then I'm going to solve. This will factor as two sets of parentheses. We have an x here and an x here. This minus means one's positive, one's negative. Positive and a negative. Now what multiplies to 3 and has a difference of 2? Well, that puts a 3 and a 1 there. There we go. Now the 3 had to be positive because the 2 is positive. And then just set each one of those factors equal to 0. Which gives us x plus 3 equal to 0 and x minus 1 equal to 0. Of course, solving just means we subtract 3 and then add 1, so x equals negative 3 and x equals 1. So there you go. Those are the critical numbers. It's fantastic. We love that. That's the first step. Find the critical numbers. The second thing we need to do is look at a number line. Now, on this number line, I'm going to put the critical numbers on there. Negative 3 and 1. At these values, this is where the function, the derivative is equal to 0. In other words, the slope of the tangent line is 0. So, at negative 3 and 1, I need to go ahead and, well, I know what the derivative is. What I need to do is I need to find test values. So here, up here I'm going to write the x's that I'm going to use. And down here, I'm going to write down what will f prime of x be. In other words, will it be positive or negative? Now I need a number to the left of negative 3, which means I can use, let's say, negative 4. That would work perfectly fine. No worries with that whatsoever. Now, what I need to do is I need to realize what is f prime of negative 4. Well, f prime of x is equal to 3x squared plus 6x minus 9. So f prime of x is equal to 3x squared plus 6x minus 9. And then I just need to find out, is this positive or negative? Well, just plug in the negative 4 into the function. Negative 4 squared is 16. 16 times 3 is 48. So this is positive 48. Negative 4 times 6 is negative 24. So negative 24 and negative 9 make negative 33. 48 minus 33 is 15. It's the only thing we really care about there, though, is that it's positive. So, but when you're to the left of negative 3, the function will be increasing from left to right. Now, between negative 3 and 1, okay, notice, frankly, if you can ever choose 0, choose 0. It makes everything easier. It really does. So, plugging in 0 into here, 0 squared, 0, we're left with negative 9. So this is going to be negative in here, which means the function is decreasing from left to right. And then to the right of 1, I might as well choose something like 2. If I plug in 2 here, 2 squared is 4, 4 times 3 is 12, 2 times 6 is 12, so 12 plus 12 is 24, minus 9 is 15, which makes that positive. So in these regions, the derivative is positive, the derivative is negative, and the derivative is positive. So what this is telling me that this function is increasing on negative infinity to negative 3, union 1 to infinity. In other words, it's increasing from here and in this region and in this region. In other words, To the left of -3, it is increasing, and to the right of 1, it is increasing. Notice that we have to use open parentheses with these. And between -3 and 1, it is also increasing, or it's decreasing in there. So for the decreasing regions, we are between -3 and 1. And there you go. Oops. Excellent. It also says to locate all points where the tangent line is horizontal, aka where do the critical numbers occur, because we set this function equal to 0. The critical numbers occur at -3 and 1, so to find the critical points, the CP, we need to find f of -3 and f of 1. That means you plug in -3 into the original function, which gives me -3 cubed plus 3 times -3 squared minus 9 times -3 plus 4. Now, if you plug that into the calculator, let me type in this original function in the calculator as x cubed plus 3x squared minus 9x plus 4. And then go to your table or just do vars right 1 enter enter, and f of -3 is 31. Do the same thing for the 1 cubed plus 3 times 1 squared minus 9 times 1 plus 4, and that's going to give you -1. Awesome. So there you go. So the coordinates where the slope of the tangent line is horizontal is -3, 31, and 1, -1. Good. Now here's just a graph of the function. All you have to do is just type it in the calculator. But notice something. At this -3, oh look, right up there is that coordinate. Right there. That is -331. And over here, this coordinate is 1, -1. Now notice that the function was increasing in this region, then it was decreasing in this region, and then it was increasing in this region. Now notice that from changing from increasing to decreasing like this, it requires that you have a maximum point. And over here, going from decreasing to increasing, that requires you having a minimum point, a relative minimum point. Alrighty. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.